Hello students. After astronomical telescope, which is a refracting type telescope, now we are going to study about reflecting telescopes. Now these are called reflecting because they are going to use mirrors, and the phenomena on which they work will be reflection. So that's why we call them as reflecting telescope. Although the work is same, they are also used to see distant objects clearly, but they use mirrors and work on the phenomena of reflection. That's why we call them as reflecting telescope. There are two major type of reflecting telescope. One is Newtonian, which was first reflecting type telescope and was made by Newton in around 1668. And after that we have another which is called Cassegrain reflecting telescope. So first of all, here this is the diagram of Newtonian reflecting telescope, in which Newton designed this telescope in 1668, and he used a concave mirror. This is a concave mirror of large focal length, and it works as objective and is made of an alloy of copper and tin. Okay, so this lens is made of this mirror, sorry, this is not the lens, this is a mirror, a concave mirror, and is made of an alloy of copper and tin. Okay, these two elements are used to form this objective mirror. When a beam of light from distant source, this is a parallel beam of light coming from a distant star or any source object which we want to see, is incident on the objective, before these rays get focused at f after hitting this mirror, so this mirror converge these rays, and these rays move towards f to get focused here. But before they get focused at this point f, they insert a plane mirror at 45-degree inclination, which intercept these rays and turn them towards the eyepiece, and where eyepiece has a convex lens. Okay, so a beam of light when coming from a distant star or an object is incident on the objective, it get converge and come towards f to get focused. But before they get focused, there is an inclined mirror, plane mirror inclined at 45-degree, introduced in the path of these rays, so that it intercept them and turn them towards the eyepiece, and we adjust eyepiece perpendicular to the axis of the instrument. So this is the axis of the instrument, and we adjust eyepiece perpendicular to that axis, and this eyepiece then form a highly magnified, virtual and erect. So the working of eyepiece is here, it make a magnified, virtual and erect final image of the distant object. So that's how Newtonian reflecting telescope work. Whenever parallel rays from a distant object hit this converging concave mirror, it converge these rays, and these rays come towards f to get focused. But before they get focused at point f, we insert a plane mirror inclined at an angle 45-degree. This mirror intercept the path of these rays such that these rays turn towards the eyepiece, and eyepiece is adjusted perpendicular to the this principal axis of the setup of the instrument. And the work of eyepiece is to make a highly magnified, virtual and erect image of the distant object that a viewer can view or observe. So that's how Newtonian reflecting telescope work. Now the second one is Cassegrain reflecting telescope. Now this telescope is going to use concave paraboloidal mirror. Okay, parabolic kind of mirrors रहते हैं यहाँ पर, that's why we call them paraboloidal mirror. And these are also concave type. It consists of large concave paraboloidal mirror, or we call it as primary mirror, having a hole at its center, right? This primary mirror have a hole at its center, and there is another small convex mirror near the focus of the primary one. So this f is the focus of this primary mirror, and near its focus there exists a secondary mirror which is a convex mirror. This is a concave paraboloidal objective mirror, while this one secondary one is a convex small mirror near the focus of the primary one, and the eyepiece is placed on the axis of the telescope only. A Newtonian may it was perpendicular to the axis, but in case of this Cassegrain reflecting telescope, this eyepiece is going to be placed on the axis of the telescope only. This is the axis of the telescope, horizontal. So on the same axis eyepiece is placed. Now the parallel rays from a distant object, these are the parallel rays from a distant object, are reflected by this large concave mirror, and before these rays get focused on capital F, there is a secondary mirror inserted in their path such that they get reflected by this mirror and converged at a point capital I just outside the hole. Now this is the point जहाँ पर ये rays converge होंगे, and after converging the final image formed at I is viewed through this eyepiece. Okay, this eyepiece is used to view the image that is formed at the point of meeting of these rays, that is capital I. Now as the first image is formed at F, this is the formation of first image F, which is inverted with respect to the distant object. The second image which is formed at I is erect with respect to the first image. Okay, so the image formed at F is inverted with respect to the first one or with respect to the object, while the image formed at I is erect with respect to the first image, that is at point F. Hence the final image that we get will be inverted with respect to object. So the final image that we get at capital I will be inverted as compared to object. This is how this telescope work. Now if f naught or fo is the focal length of the objective and fe is the focal length of the eyepiece, right? Fo is the focal length of the objective and fe is the focal length of the eyepiece. Then for the final image formed, if final image is formed at D, if this final image is formed at D, in that case the magnifying power or magnification can be given as f naught upon fe 1 plus fe upon D. While if this image is formed at infinity, if the final image is at infinity, in that case m will be f naught upon fe, or we can also call it as r by 2, that is the radius of curvature, r by 2 upon fe. So these are the values of magnification that we get from reflecting type telescope. Now why we are using, what is the need of reflecting telescope? So for that we should know the advantages of reflecting telescope. So there are certain advantages of reflecting telescope. That first one is, so the first advantage is we are using concave mirror in this reflecting type telescope, and this concave mirror of large aperture that we are using, it will have high gathering power. Okay, so this concave mirror of large aperture has high gathering power of light that is coming from the distant object, and since it has high gathering power, so because of that high gathering power, the image that form will be very bright. The final image that we will get will be very bright, and it can be viewed very easily. The object which is far away from us, it can be clearly viewed very easily by using concave mirror of large aperture. Now the second thing is, due to the large aperture of mirror that we are using, these reflecting type telescopes have high resolving power. Since the aperture is large or high, that's why they have high resolving power also. So this is the another advantage of using reflecting type telescope. Since we are using mirror instead of lenses, so mirrors are free from chromatic aberration. These are free from, so there is no chromatic aberration in case of mirrors. That means we can form image which will be free from chromatic aberration. Chromatic aberration means the formation of colored image of a white object. Since there is no chromatic aberration, so we won't get any kind of colored image in case of mirrors. The next advantage is that the use of paraboloidal mirror that we were using in case of Cassegrain reflecting telescope, the use of that mirror also reduced the spherical aberration. So by using paraboloidal mirror, spherical aberrations can be reduced. This is also an advantage of using reflecting type telescope. The next advantage is that since we are using a mirror, so we only need grinding and polishing one surface. That means the process will be cost effective and less cost will be needed to construct that kind of telescope. So if we are using mirrors, there is a need of only one surface. Okay, it requires grinding and polishing of one surface only. That means it is also cost effective and will consume less time to construct. We can construct it in less time and is cost effective also. Next advantage that we have of reflecting type telescope is if we use a refracting type telescope and in that we are using a lens of large aperture, so a lens of large aperture is very heavy and it is difficult to make as well as to get support by its edges. But if we use a mirror of equivalent optical quality, it weighs less and can be supported over its entire back surface. Lens ko we have to just support from the edges, while mirror ko we can support from whole surface, so it will be easier. So in case of lens of large aperture, if there is a lens of large aperture, it will be very heavy and we also face some problem to make it and support it at edges. Okay, it is very heavy and difficult to make and support at edges. This is the case when we use a lens of large aperture. But if we use a mirror of same quality rather than a lens, if we are using a mirror of same optical quality, same optical quality, in that case this lens can be easy to make. Okay, it weigh less, it won't be that heavy, it weigh less, it is easier to make and can be supported over its entire back surface. So that's why it is easy to deal with a mirror instead of a lens. So these are the main advantages why we are moving to reflecting type telescope instead of refracting type telescope. That's the reason for that. So that's all for the video. For further videos, stay tuned and keep studying. Thank you.